Every day, there's a new story about how 3D printers are transforming our world. From the Air Force using 3D printed parts to reinvigorate old planes, to builders 3D printing an entire house, to the medical industry using 3D printing to fabricate customized prosthetics, tissue, and even organs. There's no denying that this technology is changing the way we live. And thanks to the development of affordable, compact, and user-friendly 3D printers, consumer use is booming in offices, classrooms, and even homes. In fact, analysts estimate that about 2.1 million such printers are in use worldwide. Like so many new technologies, 3D printing is growing quickly and evolving rapidly. Just as a photocopier can reproduce exact copy after exact copy of 2D pages quickly, cheaply, and reliably, 3D printers can do the same for complex components. But unlike photocopiers, 3D printers use an additive process, and their runtimes can last for hours. Let's walk through the basics of how they work. Fundamentally, 3D printers take a digital file and use it to build a three-dimensional solid object. The most common consumer-level 3D printers use a method called fused filament fabrication, or FFF. This is the technology that was used in our research. It is sometimes referred to as fused deposition modeling, or FDM, which is a term copyrighted by a specific printer manufacturer. Either way, that simply means that the printer heats up a material, forces it through a nozzle, and then deposits, or prints, that material layer by layer to build an object. The material that gets heated up and layered to create the object is known as the filament. Think of it like the ink on a traditional printer. The two most common types are acrylonitrile butadiene styrene, or ABS, and polylactic acid, or PLA. These are both types of thermoplastics. Other common filament types include nylon, polyvinyl alcohol, or PVA, polycarbonate, or PC, and high-density polyethylene, or HDPE. 3D printers allow for great innovation and progress. But, as with so many new technologies, there are also unintended consequences to consider. There's a growing need to better understand human health and environmental risks associated with 3D printing. What pollutants do these printers emit when operating? What impact does exposure to these emissions have on human health? What factors impact the type and amount of emissions? 3D printers are widely used in industrial settings and non-industrial settings, like homes, schools, libraries, and office settings. While regulated OSHA standards manage worker exposure in industrial settings, non-industrial environments are managed by guidance and best practices. There are no regulated standards for indoor environments. And unfortunately, 3D printers are often used in small-scale, non-regulated indoor environments, especially when vulnerable populations like children are present. To learn more, visit chemicalinsights.org.